This is 5.2.4. We're told that X, or our metal plates, are normally distributed. They have a mean of 4.3, a standard deviation of 0.12. And it's talking about stacking these plates on top of each other. And then it asks, what's the smallest number of metal plates required in order for their average thickness to be between 4.25 and 4.35 with a probability of at least 99.7%? Well, first of all, one of the first things I'm going to want to do is say, okay, well, we know what our mean and standard deviation are for our normal, but what are they going to be for our average? Well, we know that our average will still be normal. And then we learned in this chapter that the mean for your averages are just going to be equal to the original mean. So in our case, 4.3. And the standard deviation for your averages, well, we first learned about variance. So the variance is just going to be equal to the original variance over n, which means something that we'll memorize lots of time. Memorize because we'll use it so many times in this class. The standard deviation will be equal to the square root of, will be equal to the standard deviation sigma over the square root of n. So in our case, that will be 0.12 over the square root of, well, we don't actually know what n is. That's our end goal. So we'll just leave it like that. Okay, so that's what we're going to have for our averages. So now we kind of know what our new mean, our new standard deviation are. So if I was to want to find a z-value, because anytime with the normal distribution, we know we're going to have to find a z-value, we would do whatever the mean value would be minus the mean for our averages over the standard deviation for averages. So in this case, it'll just be whatever average we're interested in minus our mean, which we said is 4.3, over standard deviation of 0.12 over square root of n. So that is how we would find a z-value. We don't know square root of n yet, and we're probably not quite ready to do the rest. So let's just keep that in mind. So we're kind of putting a lot of pieces together. Now let's see, what average was it interested in? It was interested in an average of 4.35, okay, and 4.25. So basically, you'd have 4.3 in the middle, you'd have 4.25 here, 4.35 here, and you want the probability or the percentage in the middle to be 99.7%. So this is the x bar value. What we want to do is, if we standardized it to z-values, what z-value will have 99%, or since we do decimals in this class, 9.997 in the middle. What would our z-value be? Well, to do this, let's do 1 minus 0.997, which gives me 0.03, and divide by 2. So that gives me 0.0015 in each tail. You can see it's symmetrical because we have 4.35, 4.25. They're both equal distances from 4.35. So I go to my normal table. Okay, so we're looking for an area of 0.0015. Looks like we're right here at negative 2.96 or negative 2.97. Looks like either way we'd have to get a calculator to get more precise. Doesn't matter which one you pick. I'm just going to say negative 2.96 because that's what I wrote down earlier. So z equals, this one was negative 2.96 when we looked at 0.0015 to the left. So this would be positive 2.96. So we have z equals 2.96, okay, and that would be for an x bar value of 4.35. So up here, we said, what is it going to be? It's going to be x bar, of our case, the one we're interested in is 4.35, minus the 4.3 over 0.12 over the square root of n. So we know what z is. We know how we were going to calculate z. So let's just put them equal to each other. So we get 2.96 equals 4.35 minus 4.3 over 0.12 over the square root of n. Now the biggest thing is you need to make sure that you work with this improper fraction correctly. So I could times both sides by, let's switch colors here. There's different ways you could do this, but I'm going to times both sides by 0.12 over square root of n. Times it by 0.12 over the square root of n. We're solving for n. So let's see, 2.96 times 0.12 gives me 0.3552 over the square root of n equals, and then so that would be canceled, and 4.35 minus 4.3 gives me 0.05. So let's see, at this point I could multiply both sides by the square root of n. So 0.3552 equals 0.05 square root of n, and then divide again. So square root of n equals 0.3552 over the 0.05, or 7.104. So coming up here, we'd square both sides, so n is going to be 7.104 squared. And we get 50.46. So we need at least n equals 51, because you can't have part of a sheet in this scenario. Now, solving that just goes back to our algebra classes. You would never be asked to solve something like that on the exam. So if you want to just stick it into Wolfram Alpha and say, please solve, that's fine. If you solved it different ways, that's fine. Okay. The main idea is we figured out, well, what would we do if we wanted to find a z-value? We figured out what our z-value should be, and then we can go back and solve for your missing variable, which was the square root of n.